Okay, hello guys. We're gonna start our third class. So I wanna give you some time at the end to solve your quiz in web work. You still have until midnight, but usually I like to leave this at least 15 minutes to work in class. In case you have questions, you can generate questions. Also, you can ask me any questions at the end. So I also want to do on Fridays like a final week review. Okay. So what did we do this week? So let me start with that. So let me share my screen. Let me see first. I have. Okay. So let me share my screen. Okay. So let me go back to the book. So this book is basically our notes. Okay. So this week we start doing the fundamental theorem of calculus, section 1.3. Then we do substitution method, section 1.5. And then we start doing, go back and do approximating areas. Okay, so we did Riemann sums. And then we're gonna continue with this approximating areas, okay? But remember that we said that exam number 1 is chapter 1 and chapter 3. Chapter 2 will be for the exam number 2, okay? So this is usually the standard approach. This chapter 2 is hardest chapter. So I don't like to start with such thing first. So, and so today we're gonna finish these approximating areas with numerical integration that is basically very similar with what we did with left hand sum and right hand sum, Riemann sums. Okay, so in this, we're gonna discuss right now the other methods we have. Okay, that is called trapezoid method and midpoint method to approximate integrals. Okay. So that's what I want to do today, this section 3.6. Well, I can do click. And then this is, we're just going to basically, I'm going to show you, I mean, this is a lot of formulas, but you'll see the meaning is just simple, okay? What we do is simple. And then you have examples, and then we have trapezoidal rule, and then we have also formula. So that's what we're going to do today. And then we're going to have the quiz. And so, so one important thing, why do we need more approximation methods? We already have right hand sum and left hand sum from Riemann, right? Well, it turns out that these approximations are better because these approximations tells you the error, okay? So there is a formula here. There is a way to approximate the maximum error you're gonna have. So when you are doing numerically the integration, you can say, okay, my estimation, because they're not all the integrals you calculate. For example, this integral, this is a famous integral that you cannot find the antiderivative. Okay, so you need to find the approximation and then find the error. So you want to know if you are going to be 0.01, 0.02 far away. Okay, and that's part of why do you have certain approximation in practice, right? when you are an engineer, you cannot solve things exactly like we do until now, right? So what you're gonna do after a point is just approximations. And so it's good that this numerical method tells you, good, you can find approximation this way, and your error is gonna be maximum this. So for example, when you saw, oh yeah, for example, good example is you saw Hidden Figures, the movie. There is a point where they're trying to send the spaceship, right? And the spaceship has to go into space and rotate, right? By gravity is going to stay around the Earth. Well, so the important part there is that they something called Euler method, that is an approximation to solve a differential equation. I'm going to put it right there here in our class. So what is interesting of this is that because she proposed, and that's what it was interesting, because we want a Black African American lady working there, that basically her job was just doing calculations, read the calculations of, do the calculations and write the calculations like we are doing. So at that time there were no computers. So here we're doing a lot of hand work, okay? That's what she was doing. But then she proposed to solve the equation numerically using Euler method. And then Euler was good because it gives you an error. So even if it was an approximation, there is an error. So even if there is an error, there is going to be error in the trajectory, but that error by physics properties is not going to be fatal. Okay, yeah, you can deviate a little bit, but then it will keep the trajectory. So that was kind of the important part of the contribution. They show a little picture of the Euler method in a book, but it's not the Euler method, it's modified Euler method or something like that. Okay? That's we always look at that in differential equations. So this is kind of that, numerical approximation. How do you solve a mathematical problem doing approximations? So this is the first part. So let me go to web work. Hopefully I'm connected. So I'm going to show you what do we have right now. So we have quiz today, due today, okay? And the quiz are 3 questions. First one, substitution. Second one, substitution again. And the last one is numerical approximation, okay? The Riemann sums, not what we're gonna do today. What we're gonna do today, I'm gonna test it next week, okay? So you have that, but you also have a homework that is the review of integration and that due on Monday. So by the way, I'm gonna do an example of some, yeah, but we'll see what time we have. And then on Tuesday, I'm gonna do integration by parts. But you can, my advice is that this weekend, you go and start watching your videos. Remember, so also I said this before, I'm gonna say it again. You go to the announcements, and it says here in advance, this was the videos for the last weekend. So you will do very good during this week. And then now you have numerical approximation, week 2, that's what we did. Left, right, and midpoints. So I'm gonna do midpoints today. Trapezoid, we're gonna do that today, but you also have it in the, you have it also in this video, but I'm gonna do it today. At Simpson rule, Simpson rule, I was forgetting that one. I don't think I'm gonna be able to do that Simpson rule today. I didn't see it in this new book that we have. But also, so you should watch these 3 videos, But you see, these videos are 5 minutes. Okay, it's not a big deal. And then you also should, I recommend you watch these integration by parts videos. Do your best to do in the weekend, but start right away in your homework. Watch 1 or 2 videos and then start right away in your homework, okay? Then you'll generate questions, and then on Tuesday, I'm gonna cover integration by parts. And this homework due on Friday, I think. Or when is 4? The 4 is Friday. But you know, you let me know. I can give you more time if several people require it. But I really need you to, during the weekends, go ahead and watch these videos and start right away your homework, please. Be that kind of a student. Unfortunately, I was not like that. You know, you discover that later. I mean, I discovered that in graduate school. At graduate school, and somebody's asking me help on this question 3. Yeah, I will discuss that in a second. I can help. So I was not that kind of a student, my undergraduate. And maybe I did with one class I really liked, and that's what I do right now for my research. And I just, when the class finished, I went and started solving the problems by myself. What the problems that the professor worked in class, I started doing it by myself to see if I can remember. Then I got stuck. I said, "What is stuck? I just saw this done." So I went and I said, "Oh, this is important detail." And then that's what I did all the time in graduate school. And that's really good. That's when you really understand things, okay? And then even better is you, before your class, you go to some of these videos and start solving. You know, on my time, they was not available. And the kind of math I do in graduate school, there is no videos for that. It is too advanced, Nobody's gonna, well, maybe now there is a lot of YouTube stuff. So yeah, you can find today a lot of those advanced. But before, no, but now you have all this ability, guys. You're gonna do extraordinary. But you know, you have to take advantage of all these possibilities we have.
They're coming in, but it's not like a straight line.
Yeah, they're merging into you.
Let me mute this person. Okay, so so we have both. We have these videos, integration by parts, and also trapezoid and midpoint. I'm not sure Simpson. I'm gonna see if Simpson is in the book. If Simpson is in the book, I'll do it on Tuesday. Okay. But for now, I'm gonna do midpoint and trapezoid rules, and then we talk about the quiz. Okay. I can even solve the third problem of the quiz to help you. But that's what happens pretty much this week. Okay. Okay. So let me go. Let me cancel now my video. Well, not cancel. I'm gonna disappear from my face is gonna disappear because I'm gonna start working on this numerical integration. Okay. So. You guys are watching my screen, right? So let me see what was here. So that was yesterday. So we were doing Riemann sums, right? The left hand sum, right hand sum. And we did some exercises from Wedworth. Yeah. Okay, so let me start a new section. Lecture 3. And we're gonna do today midpoint rule, and well, let's put and trapezoid and trapezoidal rules. Well, let's put the midpoint and trapezoidal rules. Okay. So we're gonna.
You take your vitamins?
Let me find this. Who's talking? Let me try to find it to mute. Everybody's mute. Okay, I don't know why. Okay, so we're gonna do the midpoint. So we were working on the integral. We're gonna do the same example with it, with the same function. That's what I mean. So let's start with midpoint. Midpoint rule. So now, what I'm gonna do. So please, I hope you guys are taking notes, okay? So we're gonna do again the integral between 0 and 1. 0 and 1. And again, we're gonna use n equals 5. So the increment is gonna be a 1 minus 0 over 5. That's 1/5. Okay. And the midpoint rule is very easy. Since we already know, that's why I'm doing this method now, because you guys are already familiar with the Riemann sums, so I don't need to waste time recovering again Riemann sums. We just did it, so we're gonna continue. That's what I'm doing. This is section from the book. This is section 3.6. So yeah, I'm skipping a lot, but because it's related. So this is section is 3.6 from the book, but it's connected to what we just did, and it's gonna be in the exam. So again, what I do is divide in five little intervals. So 1, 2, 3, 4, and 5. So my first is 0, my second is 1/5, my first is 1/5, my second is 2/5, 3/5, 4/5, and 1 that is 5/5, right? So what is different here? So what do you think, guys, is called midpoint? What do you think we're gonna do? So let's say you're in Texas and you're walking with your gun. So left hand sum, we shoot our gun over here on the left. Right hand sum, we shoot our gun from the right. So we shoot it here, 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 and here. The left hand sum, we hit it on the left. 1, 2, 3, 4, 5. Okay. So what do you think midpoint is gonna be? Where we're gonna shoot? Any ideas?
3/5.
You have to use the middle, like between 0 and 1/5. You have to do 1 over 10, so because that's in between
Exactly.
those.
Yes. So we're, let me choose one that is not. So for, let's say between 1/5 and 2/5, I'm not gonna choose the left or the right. I'm gonna choose the middle. So I'm gonna shoot in the middle, and then that's gonna be my, well, and sorry, it's because it's so small. I'm probably, oh, I'm gonna have to make. Let me see if I can make it bigger. Yeah, I can make it bigger. So let me raise this. So you shoot in the middle, and then that's gonna be how high my interval is. So I shoot in the middle, and that's how high my horizontal line goes, and that's my interval. So I shoot in the middle, and then this is how high my interval goes. And again, I shoot in the middle. And this is how high my interval goes. And again, shoot here, and that's how high my interval goes. So obviously this is a better approximation because it's not left, it's not right. So it's like you go in the middle. It's probably the best way of politics, right? You can also, you go in the middle, you make people, not everybody's angry with you. You go by the middle, probably. I don't know. So this is the midpoint. So let's write our sum. So how is our sum is gonna look? Our sum is gonna, let's call it a middle point. So now I can do a smaller again. Let me make my draw. So midpoint. So midpoint area or approximation. No, let's call it midpoint rule. Okay. So we need to start finding the areas of these guys. So what is the area of the first guy? So the area of the first guy is base. What is the base of the first rectangle? So and also I have here f of x equals x squared. Okay. So all the rectangles have 1/5 of base. So remember, area rectangle, we're saying base times height, right? So will be 1/5 is the base times the height. What is the height?
It'll be the 110 square, right?
110 squared, correct. So I need to find the midpoints. So guys, tell me, the midpoint here is 110. What is the midpoint over here?
210, 2/10.
Yeah. So basically, well, maybe no, 2/10 no, because 210 is 1/5. Okay. So how do you find the midpoint over here? So you that's probably we need to discuss that. So you find the midpoint with this formula. Let me put it here. So to find the midpoint, you go. Yeah. Okay. Let's say midpoint. Oh, sorry. Oh my God. Midpoint of an interval. AB. So somebody knows the midpoint of the interval AB? What is the formula for the midpoint? It's not B halves. Somebody tell me. What happened? My ladies, where are my ladies? I have a lot of ladies in this class that talk a lot. What happened to them? Hi guys, boys and girls, where is the middle point of the interval AB? So the midpoint is, you might not believe it, but it's A plus B divided by 2. That's the midpoint. So for example, let's say you don't believe me, okay? So we know the midpoint of, what is the midpoint of 4 and 5? We know that one, right? What is the midpoint?
4.5.
4.5, right? So by the formula, this is 4 plus 5 divided by 2. That's 9 divided by 2, that's 4.5. So it works, okay? So here, my midpoint for the first one, so it's 0 plus 1/2 divided by 2. 0 plus 1/5 divided by 2. So that's why it's 110. The next one, So who tells me what is it? What is the midpoint between 1/5 and 2/5? 1/5 plus 2/5 divided by 2.
6/5.
So we got 1 plus 2 is 3/5, and then divided by 2. So look at this fraction, guys, because I'm not gonna do this many often. This
2/10.
times 3 and this 2 multiplies times 5, right? It's called the Erin law. Don't forget your fractions, multiplication fractions. So that's gonna give you 3/10, right? So this guy over here is 3/10. And it looks like we know what is happening. This is 1/10, 2/10, 3/10, 4/10, right? So what do you think is here? Which one is this, guys? What is this midpoint? Between 2/5 and 3/5.
1 mid.
What is it?
5/10 or 1/2.
It's correct.
Half.
So there's my people. Yes, 5/10. So 1/10, 2/10. 2/10 is 1/5, right? 3/10, 4/10, 5/10. So this one is 5/10. Well, but anyway, so let's start writing our formula of midpoint. So I got 1/5 times the middle point square plus 1/5 times the middle point square of the second rectangle. We said that was 1/10, 2/10, 3/10, right? Yes or no?
Yes.
Okay, plus 1/5 times the middle of the next rectangle. What is the middle of the next rectangle?
1/2. 1/2.
4/10. So 1/10, 2/10, 3/10, 4/10, 5/10. Or 1/2 is true, but I want to put in this term so people follow what I'm saying. Then plus 1/5 times, so we already, this guy is done. And then we do 4, 5/10, 6/10, 7/10, right? So the next one is 7/10 square. And then the last one, so this one is 7/10. So the last one, what is the last one?
9/10.
That's 1/5 times 9/10. This is actually, this is good for practice for statistics. In statistics, midpoints are really important. And it's easy to get it wrong. So you see, I did 1/5 of all those middle points, so I could factor. So let me erase this so I can put it nicely. Well, that's fine. Let's put it here in the next. I'm gonna factor my 1/2 as always do. So if I factor my 1/2, my 1/5 is 1/5, and then I get 1/10 squared plus 3/10 squared plus 5/10 squared plus 7/10 squared plus 9/10 squared. And that will be, when you put this in the calculator, that will be your approximation. Okay, so let's compare with the book. Let's see those. Let me see all this. I have a lot of text messages, so let me see what are they saying. Okay, they're just saying. You guys can just. It's hard for me to read the chat. You should just talk. Okay, speak up so I can see you. I can hear you because otherwise I cannot see. Okay, I saw the. So let me go to the book and let's compare with the book. What is the book doing? So the book, I'm gonna do the midpoint rule. And this is the midpoint rule. You see, is delta x is my 1/5 because it's b minus a divided by n. So I had 1 minus 0 divided by 5, right? So this delta x, this is 1/5. And this is f of m of i. Mi is my middle point. So I have to find my middle point on each interval. And then I evaluate on f, in this case, x squared. So that's why we take the square of each of them. And then we make the sum. So in this case, n was 5, so I did this 5 times. So that's what I have 5, right? 1, 2, 3, 4, 5. Okay. Now you can follow the book, and the book is gonna do M4. So we did M5. Okay. So they're gonna do with 4 intervals, not 5. So 0, 1, 4, 1, 4, 2, 1/2, 1/2, 3/4, 3/4 to 1. So they only do 4. So you can do 5 interval, you can do 4, you can do 3. Most of the time people do 10. But to do a good approximation, you probably can do 100. But for that is good the computer. So you just do this in MATLAB, for example. And then you get 1/4 of F14. It's what we were doing. So they just find the midpoints and then evaluate it and then find the answer. Okay, and this is the approximation. So and now they are doing M6. So the book do M4. Oh, but they're doing for 1/2 of x squared. Okay. So this is just another one. Okay. So we're gonna move on to the trapezoidal rule now. When somebody's asking me about the pattern, let me check. So they're asking me if these patterns, this formula is for any function, not just for x squared. Okay. So if you want, let me write the formula then, so there is no confusion. So my formula for midpoint rule is the following. So let's write the midpoint rule formula. So suppose you have another function, right? This is A, this is B. So, and this is f of x. So my midpoint formula is if n equals b minus a over n, that's my number of, my delta x. This is my delta x. My delta, this is my delta x. Is b minus a over n. So what does it mean? It means I'm gonna have n intervals, okay? 1, 2, 3, 4, 5, until n. And now my formula is my midpoint rule goes like that. So you do the delta x, that is the base, this is delta x, and then you shoot, and this is your rectangle. And then let's call the midpoint n1, like in the book. The book is calling n1 the midpoint. So let's call the midpoint n1. Oh, n1. So this guy is n1. This guy is m2. So the formula, you want a formula, so is delta x times the midpoint, f evaluated the midpoint 1 plus delta x evaluated the point in the middle, and f times f evaluated at the middle point 2 plus delta x f of the third middle point, and so on until delta x f of m sub n. Okay, but you know, we already say that you can just write this as or you know this from your calculus, that and your pre-calculus, that you can just use this notation, f of delta x times f of mi when I equals 1 to n. Okay, so that's the formula you can use. Okay, and that's the formula they have in the book. So you go to the book. That's the formula they're showing over here. Sum of I equals 1 to the n f mi m f of mi delta x. Okay, that's the approximation. And if you take, if the biggest the partition is, you have 1,000 of partitions, then you are really close to the integral. When the limit goes to infinity, this partition is gonna become the integral. Okay, so that's something you'll also learn in calculus. But let me say it here. When you take the limit, I'm gonna review this kind of review that. When you take the limit of n goes to infinity of the sum I equals 1 to n of, let's put it like this now, f of mi delta x, okay? So this limit is gonna be what we consider the integral between a and b f of x dx, because it's the area, no? We said this guy is the area below the function between a and b. So clearly we're finding an area because we're approaching with rectangles. So the limit with this guy becomes the integral with the x. Okay, so that's how it works. Okay, so it was longer than I thought. So we're gonna do now the trapezoidal rule. And now this is even easier. I'm not gonna go over the derivation. I'm just gonna give you the formula. You already have probably enough of the with the Riemann sum left and right, and now midpoint, now trapezoidal. So this is probably gonna be the last one. Not sure I'm gonna do Simpson rule. Oh, Simpson rule is also easy. Well, we'll see. So, so the trapezoidal rule is a formula. So trapezoidal rule, right here. Trapezoidal rule. So the trapezoidal rule is like this. So same thing, and I just tell you this, Tn, this is notation. So let's call this, let's call this guy M sub n for midpoint. This is midpoint because you have n intervals, okay? Let's say this is gonna be your formula for midpoint. And that's all that I'm gonna give you, okay? So you know what is delta x, what is mi, so I don't need to explain that. And the trapezoidal rule, so this is like this. So 1/2 of the delta x, and we know delta x is d minus a over n, right? And then it goes like this, f of x0 plus 2f of x1 plus 2f of x2 plus, you continue, 2 times f of x n minus 1 plus f of xn. Okay, so let's talk about this. So this is the trapezoidal rule, and x0, a is x0, and b is xn. Okay, so basically you divide your interval. So let me draw the function. So this is your function, this is a, this is b, and then this is gonna be x0, and then you start x1, x1, x2, x3, and so on. Start dividing, right? The last one is xn. So you start making your those are gonna be the base of your rectangles, okay? Those are gonna be the base of your rectangles, x4, and so on. But then what you do, you don't even have to think too much, right? So you put f of a of x0 plus 2f of x1 plus 2f of x2 until f of xn, that is the last one. So let's do our approximation for the integral. Let's do our trapezoidal rule for the one we're doing in all the examples. So we're gonna do our example for the integral between 0 and 1. Right? So we are gonna do n equals 5. So we're gonna do delta x equals 1 minus 0 divided 5 is 1/5. Okay? So I have my delta x, and I just need to know x0, x1, x2 until xn. So xn, so I know x0 is 0, right? This is x0. And what is 1? 1 is, so you guys tell me, what is 1?
XN.
And in this case,
We x5.
x5. So I'm gonna put my partition. Oh, x0. Yeah, we have let's see, 0, 1. Oh yeah, that's good. That's good. Sometimes they give us trouble, but this is good. So this is x1 is 1/5, 2/5, 3/5, 4/5, 5/5. So and just for because it's the first one, x0 is 0, x1 is 1/5, x2 is 1/5, sorry, 2/5, x3 is 3/5, x4 is 4/5, x5 is 1. Okay, so to apply my trapezoidal rule formula, and it's over here, all that I need to do is do 1/2. So I'm gonna do my trapezoidal. So it's 1/2 of delta x. So delta x is 1/5. And then I need to do f of x0. So f of x0 is 0 squared. Plus, and now my trapezoidal say the 2 times f of these ones that I mark. Okay, x1, x1/5, 2/5. So I have to go 2 times 1/5 plus 2 times 3/5 plus 2 times 4/5. And then finally, what do I write? Plus what? Oh, sorry, 1/5 squared. Oh, sorry, let me see. Yeah, I put, it has to be evaluated as the function, right? So square. And my last one is, what is my last one? 1 squared without the 2. So notice that in trapezoidal rule, the first one and the last one don't have the number 2. Everything else has the number 2. Okay? And questions? Do you guys have questions? No questions? So, so no questions, guys? I'm deciding to do, yeah, let's leave it like that for now. I probably can do Simpson rule on Monday, on Tuesday, to start with. Okay, so I want to leave these last minutes. We have, wow, oh, we're good. We still have 25 minutes. So please go to your quiz and let's solve the quiz. Okay. I'm gonna stop sharing. Please start making the quiz. You have until 12, but probably eventually I'm gonna make the quiz for the people at synchronous in class. I think that's what I'm gonna start doing. depends how much how good I'm doing during in the syllabus. So if I'm not behind, I can do some Fridays. I can give you the time for the quiz, and the quiz is gonna start and end during the class. For the people taking the synchronous class, the people that is asynchronous, I will let you. I will give you more time. But okay, question here. Wait, what we are supposed to type? Can you explain what we are? I'm reading a question. Can you explain what we're supposed to type in the assignment? Names approximation. There is a question where it has 6 lines. How are we supposed to solve it? Which question? Please tell me. I can go to approximations and see what questions. Who is this? I don't know if it's Shelly or somebody else. Not sure. I don't see the name of the person. So you guys tell me. Somebody's asking me to go to approximations. I don't know what. You need to tell me exactly what questions you want. I'm gonna check to see if I understand the question. But please start working your quiz. So you ask me questions. If you want, let's start with the last problem. Guys, about the quizzes, I'm planning to have uh, one quiz online like today, and next week the quiz is gonna have you are gonna have to solve the problem by hand and submit it in Blackboard, and then we will grade it. Okay? Because I need to give you feedback, and you need to have the exercise to write in your solution very clear, very careful, explaining your arguments. One problem with Wellword is that we become really messy. We just find here, right here, cross, and we're not very organized. So that's the only problem with Wellword, that you need to be able to write your ideas very clear, very clean, very organized. So please always, oh, I forgot to say this. This is important. You should have one notebook. When you saw one notebook where you write your notes, and another notebook when you solve all your problems. Okay, that's the best practice. So you try to be organized, you try to be clean, and then you can go back and solve you and prepare for the exam. If you just start solving in pages everywhere, they're gonna be everywhere and they're gonna be a mess. You start the problem and you don't even find it. So you need two notebooks. One notebook for your notes and one notebook for the calculations for your webwork. For this exam, for this quiz, you don't have to email me anything for this quiz yet. Okay. Next week, for that quiz, you're gonna have to solve it by hand and upload it in Blackboard, and we will grade it. Okay. Here, this quiz is basically you just need to get the answer right in Webwork. But next week, you'll have to write it down like an exam and upload it in Blackboard before 12 p.m. Okay. So let me give you 2 more minutes for people to work. Okay, let me answer some questions. So let me share my screen. I'm gonna go to my quiz. So we go quiz 1 here. So this is problem 2, problem 3. So they're asking me so notes. What is somebody telling me? Somebody's telling me that I don't see the chat anymore. Anyway, so I don't think this has any problem. So first, you see, what are you doing? Which you guys can tell me. Are you doing this one is left hand or right hand? Right hand sum. What do you think?
Left.
Left. Oh, it even says here, right? The left endpoint. So we start 4, 5, then 4.5, then 5, then 5.5, and so start on the left, right? So all that so the question is here, the value of this endpoint Riemann sum is. So I hope you guys can do that. And this Riemann sum is overestimate, equal, underestimate. There is an ambiguity. What do you think? This is overestimate or underestimate?
It's
Overestimate, right?
Over.
This is overestimate. And now for this one, this is what?
Under.
Underestimate. Okay. Now all that you need to do now is just plug in the values, right? So the values is that will be, so here we have how many part, what is n in this case? In this case, what is n? N is basically the number of rectangles. How many rectangles do you have?
8.
You have 1, 2, 3, 4, 5, 6, 7, 8. So the increment, you can see the increment right here, right? By I. What is the increment by I?
0.5, half.
One half. But you can do it by hand because let me see what is happening here. Because you have the increment is I think a 4 to a, right? A minus 4 divided by 8, because the is from 4 to 8. So a equals 4, b equals 8. We have here b equals a, letter a equals number 4. So we got 4 divided by 8, chan, 1/2. So our increment is 1/2. So all that we have to do is what? 1/2. So we have to do, we start with 1/2 times f of who? F of, what is the first, actually evaluating what is the first number? F of what? Is left endpoint Riemann sum, right? So F, because that's where I shoot. So you are shooting on the left hand side of the rectangle. So you shoot at 4, right? So this is f of 4 plus 1/2 f of who? F of
4.5.
4.5 plus 1/2 f of
5.
5, and so on. Okay. But what is F? F is, what is my function? What is my function? F of x equals F 15 over x. So this is 15 over x. So what is F of 4?
It's 3.75.
Well, let me write it like in terms of without division. What I will write?
15 over 4.
15 over 4. Thank you. Plus 1/2. Then the next F of 4.5.
15 over 4.5.
4.5. And so on. Okay? I'll let you finish because it's a quiz. I don't want to do everything. But I can show you here. You keep going and I can show you the solution here. Well, what are we doing? F of 4, 0.5 plus F of 4.5 times 0.5 and so on. And then you start calculating your calculator, you should get 10.8806. And for the right-hand sum, you start over here. You start in 4.5 times 1/2 plus F of 5 times 1/2, and the last one will be F of 8 times 1/2. And then you add that, and that's underestimated. Okay? So keep working on that quiz. Somebody was asking me about the approximation. So let me go to approximations. Well, I guess I can do it here. Approximations. Approximation, not this one. Oh, maybe this one. Yeah, so here, use the left and right sums based on diagrams above will infinitely conclude that. So, so you have to find the left-hand sum and the right-hand sum. Okay, so let me show you the solution. This are the left and right-hand sum. I think this probably has a typo. Let me check. Maybe it should be only one. Yeah, yeah, sorry. Oh, let's see. 19.5. Why the last one is different? Oh, yeah. Sorry, the second one is repeated. Sorry, guys. This second one, it shouldn't be there. It's just the same as the first one. Oh, no, the first one. Oh, no, they're different. 357, 35. No, this is good. This is good. So you just have to find the approximation. Somebody was asking me, so I was wondering if there was a mistake. So you just find the Riemann sum, the left and the right, okay? And just one you calculate between 3 and 5, the other one is between 5 and 7, the other one is between 3 and 7. So you just calculate and put the left. So what happens is that sometimes probably you're gonna get the the left or the right hand sum, they're gonna be different. You see, since it's not clear here that this is an overestimation. It's not clear if this is an overestimation. You see? Because it's concave down. So this exercise is to show you that sometimes the left-hand sum can be an overestimation or can be an underestimation. And the same for the right-hand sum. So this is just a job to see that if the function is decreasing, increasing, or both, because this is increasing and then decreasing. So those approximations are not always underestimate or overestimate. It can vary. Okay, no, but the problem is correct. You just have to do 3 times this. But this is a good practice because then for the exam you're gonna be really good on the exam. Because you just know how to do this very good. Okay. So any questions, guys?
No, sir, not at the moment.
Okay. So just work on your quiz. I'm gonna try to do Fridays not that heavy. I'm gonna try to on Fridays try to solve questions and but also work at least half of the class on the quiz, so you guys know what, or in the homework, the questions from the homework you have. Okay, so you guys don't have questions, I'm gonna stop the video so I can load it. Okay, I'm gonna load it in the week 1. Okay, so if no more questions, I'll let you go, guys, and have a nice weekend.
Thank you, sir. Good day.
Okay.
Thank you, sir. Bye, sir.
Okay, bye, guys.
Sir, I have a question
Yes.
about the approximation. Yeah, so about approximation problem
Yes.
1.
Approximation problem 1.
Yeah. We need to solve the integral to find the approximation.
Okay, hold on. Let me open it.
Okay.
No. No, you just do as we are doing. Let me share my screen. So you just do as we are doing. You just do A is 0, B is 12, and your f of x is 3x squared plus 4x plus 1.
Oh. I get
Because
it.
it's left, you need to the left-hand side with three intervals, and the right-hand side with 3 intervals. N equals 3, you see? N equals 3, N equals 3. So you just do 12 minus 0 divided by 3. That's gonna be 4.
4.
Delta
4.
X is 4.
Yeah. 4 times the equation to I need to substitute the x.
The 0.
Yeah, for 0 and 1 and 2 and 3.
Well, in this case, 0, 4, 8, and 12.
12. Oh.
Well, if it's left-hand side, you just do 0, 4, and 8. And if it's right, you do 4, 8, and 12.
Oh. I get it.
Okay.
Thank you, sir. Okay.
Okay, sure.
Thank you, sir.
Sure.
Bye.
Bye.